Thank you. Okay, similarly, if I go to my circle class, I also have a constructor, and I'm going to make use of the color, which is coming from the shape, and I'm going to make use of the radius, which I have defined here. Okay, we'll talk about the super keyword also. Like this abstraction is like this is a very huge concept, so we'll go line by line. Okay, so we first need to know like why do you want to use the abstract class? That is, we are just showing the functionality, and then we're going to define the functionality. How are we going to set pass the values? That is through the constructor. Okay, constructor means it's a simple, it's just like it's a special method, so which has the name of the class name. Okay, and from the shape I'm getting my color. From the and from the two variables which I have declared, I'm going to get the length and the width, and I'm going to assign them. So whatever length I pass it, it is going to set as the length, and whatever width I'm going to pass, it's going to set as the width. So when I'm so if I write this line, if I write shape S1 equal to new circle, that means I'm going to call the circle method here. Okay, my circle method has two parameters, color and radius. So if I pass the first parameter, this is going to be as a color. So color is of type string. That's why I gave the color as a color in double quotes. Suppose if I put it in a single, if you don't put it as a single quote, this doesn't know. Okay, so whatever you mentioned in the constructor, it is going to take it. So my constructor is accepting a string here, so I'm giving as a string. Next, double radius. So it is of type double, hence I'm putting it in a double value, a 2.2. So if you hover on the circle, you'll get to know that okay, my constructor is accepting a color and a radius. So from my S1 object, I can access the circle. I can access all the properties of the circle. So if I print, so if I print s1.to string, I'm going to get the color, and if I print s1.area, I'll get the area of the circle. So now just see the output here. Whenever I'm running this, first my shape constructor is getting called because my circle is calling the shape. Shape is your superclass here. So class name is shape, my method name is shape. So this is my constructor. So whenever you're going to run any class which is extending the superclass, the superclass will be instantiated. First shape constructor will be called, and we are going to assign the color within this constructor. After this, circle constructor will be called circle. So now you'll get to know the meaning of the word called a keyword called a super. Super keyword will be used to call the instances or to call the methods within your superclass. What is a superclass? That is a shape class. The circle is extending a shape, so shape will be your superclass. So if you want to call all the if you want to call the instance variables, if you want to call the methods, you simply write super dot some method. Or if you want to pass a value, write super and pass the color. So let me take it in another way. Now let's say I have a shape. Let's say this is a method. Okay, if I write now super of color means it will obviously call this method only because this is the only method. This is the only constructor which is accepting color, which is accepting a string value. Okay, here this is not accepting any value. Here even this is not accepting any value. This is not accepting any value. This is the only method which is accepting the color here. So if I type super color, that means it will directly go and hit this method. That's why the very first time shape constructor is getting called here. Now, if I go now the next line, circle constructor is called. So I got the second one. Then I'm going to instantiate the radius also. Like whatever radius I'm passing, I'm setting it as the radius. And at last, I'm just printing it. So my S1 object has the color and it has the radius value. Simply, I'll call the s1.area method. If I open this is the method. So with with this, we covered three major concepts. One is the use of abstract classes, one is the use of constructors, and the super keyword. Okay, any doubt till here?
No, bro.
Okay, cool. Okay, now let's take now within a slideshow we saw that this can be obtained using abstract classes or interfaces. Okay, so now whatever we discussed, that is purely abstract class. So what is an interface? As you saw, my shape is an abstract class. It has abstract method and it has normal methods also. Normal methods. But if I go to my interface class, okay, let's say the keyword for abstract class is abstract, and the keyword for interface is just interface. Interface and the class name. Okay. The difference between interface and abstract class is that interface assumes all the methods are abstract. For a method to be abstract, it should not have any body. That is a thumb rule. Okay. Double area, string to string. So these do not have any body. Now, if I uncomment this line, I'm defining a method here, get color, and it is having a body. It will clearly throw me a compilation error. If you hover on it, it will tell you abstract methods do not specify a body. So by default, my interface thinks that all the methods which are defined within the interface are abstract. That's the difference between an abstract class and a interface. Within your abstract class, you can have abstract methods and a normal default methods also. You can have your constructors and you can have your concrete methods also. But within an interface, you cannot have any concrete methods or constructors. You need to only have abstract methods. That's the only difference. Clear? Okay. So constructor in Java is a special method that is used to initialize the objects, which we have just covered. So the constructor is called when an object of the class is created. So shape S1 equal to new circle means S1 is the object, and it's going to create an instance of the circle class, and it can be used to set the initial values of the object. So constructors must have the same name as the class within which it is defined, while it is not necessary for a method in Java. So the constructor should have the same name as the class name. Okay, but this is a method. So method can have any name. Constructors do not have any return type, while the methods have return type. So I'm just we're just differentiating between a method and a constructor. If you see this method, it has return type called string. This has return type called string. This has return type called double. But if you see the constructor, this does not have any return type. It is used only for initialization. Okay, so constructors are called only once at the time of object creation, while methods are called any number of times. Meaning, so constructor circle is created with S1, and I'm invoking the constructor of rectangle with S2. So I did only once. I created S1 and S2 only once, but I'm using it 2 times here. S2.toString, S2.area. Tomorrow I can use multiple times. I can use it for S2 dot S2 dot let's say if it's some other object at area perimeter, calculate the partial area, whatever method it is, I can simply use the single object here. Okay, so constructor can this is invoked only once, and this object can be invoked multiple times. You like whatever method you want to invoke, simply use that object. I just someone raised hand here. Okay. Next, a construct in Java cannot be abstract, final, static, or synchronized. So we discussed, right? Like if we declare it as an abstract method should not have any method body. So that's not, again, not possible. So construct in Java cannot be abstract, it cannot be final, it cannot be static, and it cannot, or it is not synchronized. Okay. Now we are going to the next concept called polymorphism. Any doubts in the abstraction? Like we discussed three major topics here: abstraction, the constructors, and the super keywords. If there are no, then let's move to the polymorphism. This is our third concept in our Java OOPS. Okay, so if one task is performed in different ways, it is known as polymorphism. Meaning, the ability of like let's say I have one class and I'm using a class for multiple tasks. Okay, if that class is able to do those multiple tasks, then that is called as polymorphism. So this can be better explained within by using an example itself. Okay, let's take a banking example. Okay, I have a bank class and I define the rate of interest as 0, a normal bank. Okay, let's say this bank has a central bank. Okay, which is governing all the subsidiary banks. Now tomorrow bank A opens and it is going to extend all the properties from the central bank. Okay, and this bank is setting a rate of interest as like 10.8 f. It's a float value. Okay, tomorrow some other bank comes and it offers an interest of 13.4, and this bank is also complying all the rules of the main central bank. It's extending the bank. Similarly, I have a bank C and it's extending all the properties of the main or central bank and setting a rate of interest as 8.5 f. Okay, now mm, now let's take a bank. Okay, bank is my central bank. I create an object out of it and I'm going to instantiate this with the bank A. This is R, this bank A. Okay, and I'm again going to create an object of bank and I'm going to instantiate with bank B and bank 3 with bank C. So all these are objects of the class called bank. Okay, bank 1 is an object of bank 2 is an object of bank, and bank 3 is an object of bank. But we're instantiating it to bank A, bank C, bank B, and bank C. Now, let's print the interest of bank 1. Bank 1 dot get interest, bank 2 dot get interest, and bank 3 dot get interest. Okay, I'm going to print the interest rates of these three objects of the bank class. Okay, so the ability of an object of the same class to print different values. You see this? You see the output here? My object is my bank object only, but this object is able to print different values from its subclasses. Like whatever is the rate of interest in bank A, my bank class object is going to print. This is able to print 10.8. Whatever interest is in bank B, my bank object bank 2 is able to print it. So the ability of an object to have different forms. This is called as polymorphism. Meaning we are referencing some object to the subclass because bank A is a subclass of bank. Since bank A is extending the bank. Since bank A is extending the bank, this is a subclass, this is a superclass. So I'm going to create a object of the bank and I'm going to instantiate with the subclass and whatever is there here, we are going to print it using the bank. Getting this? Objects are from the same class. Bank 1 is from bank 2 is also from bank 3 is also from bank only. We are in the same class, but it is exhibiting different forms, 10.8, 13.4, and 8.5. This is called as polymorphism. Ability of ability of the object of the same class to have different forms. Understood till here? This is quite tricky. That's why I just took some time. Even if you're not able to understand, just please let me know. Okay, let me take that signs as yes. Okay, now we have some concept called as upcasting, meaning we are going to point the reference means the object to a subclass. This is a superclass and this is a subclass. So pointing the reference of my superclass to my subclass, this concept is called as upcasting. Okay, so everything is like if you open the notes here, so each and every package will have a note section also here. So whatever we're doing in the example, we wrote it here itself. So whenever you clone the source code, right, yeah, you'll get all these notes. Okay, so with this polymorphism, like you'll get to something called as upcasting. If we have any doubts, just let me know. Else we can move to the next concept, encapsulation. Okay, okay, let move to encapsulation. So binding or just a minute. Let me plug in my charging. Okay, so binding or wrapping the code and data together into single unit is called as encapsulation. So like whatever source code which we have, we are going to wrap it up in a simple package. So that is called your encapsulation. So Java class is just example of encapsulation. So this is fully encapsulated, meaning whatever variables which are going to define within our class, those are private. Okay, we're going to take a look at them in the example. So so let's say like I just created a class called as encapsulation. Okay, so my class is within my package. Okay, this is called as a package. So within our whole source code, Java Basics is called the project. SRC default package. So if there's no name for anything, that's called the default package, and else everything is called as a package. And within the package, you have your classes, interfaces, everything. Okay. Now let's say I have one class and I have a name and an age. These two parameters. These two are declared as private. Okay. These two are declared as private. Now, if I want to just a minute. Sorry, just a minute. Let me explain you like the accessibility of this private and so okay. Do I have it in the next slide? Okay, I do have it. Okay. Okay. So we have name and age, and since these are declared as private, I cannot access the name and age directly. I need to have something called as a getter and a setter to set a value or to get a value. Okay. So we write something called as get name and we return the name. If it's a getter method, and if it is a setter method, you're going to pass the name and set that name to the name variable. Okay. So So let's say let's say you have a student class. Okay, a student has a name and an age. So you declare them as private. So these are not accessible to anyone. Their name and their age are not accessible to anyone. But if they want to set a value and if they want to get that value, you need to have a getter. So Eclipse has a shortcut, Alt Shift and S, hit R. You can generate your getters and setters. Just select age and name, click on generate. This will automatically generate for you. Okay. Okay. Now let me take a main method again. I'm going to instantiate my encapsulation method class here, like E. Now I'm going to set the name. I'm going to set the name as tetra in this encapsulation class. How? With the setter method. So E dot set name. This is called a setter method. Let me take you to that. If I just click on control and open the implementation, it is coming to set method here. So and it is expecting a parameter called as string name, a name of type string. So E dot set name and tetra. So I'm passing this tetra as in the type of string. So it'll go to this method, and with this method, it's going to set the name as tetra. So the value of my name is tetra. So I'm going to set the name of my private variable using a public method. Okay, this call is encapsulation. These are highly restricted, and if you want to access these values, you need to access them only with getters and setters. That's why variables are declared as private, whereas their getters and setters are set as declared as public. So if it is a get name and get age, it is called as getter. If it is set name and set age, it is called as a setter. Getter and setter. So if I'm going to set my age, and this is 20. Okay. If I hover on this, it is expecting int age. So if I go to my set age method, this is the method. I'm passing age. If this age parameter will come here, and it is setting this age value to 20. So simply now, if I want the name, simply type e dot get name. What my get name will do? It will return the name, which we already set it here using this setter method. This way. Getting it? Like why do we need to use getters and setters? Yes, no. Okay, as yes. Okay, so with this we have better control on all our on all our variables. Like tomorrow you'll be working with lots and lots of variables. Like let's say if you take a simple sign up page within your application, your sign up page will ask you for a name, password, and your age, your email, your date of birth. So all these are called your what you call attributes, your variables. So private string name, private int age, private string email. So each and every page, whatever attributes which you see there, those all are called as a variable. So you're going to declare them as private, and then you're going to use the public getters and setters to set and access the values. Okay, so this like this will increase your security, and this also increases the flexibility also, the way you use it. Okay. Next comes your data hiding. So I think all these concepts are inbuilt concepts within your Java OOPS. Okay, that's why. So we just covered OOPS concepts so that all the concepts will be covered when we are explaining them. So data hiding is a procedure done to avoid access to the data members and data methods and the logical implementation. So it can be done by using the access specifiers. So we have default, public, private, and protected. These are your access specifiers: default, public, private, and protected. Okay. So let me take it by example. Okay. Just take this as a simple class. A simple class. It has a method, but it does not have any specifier. Like we didn't specify it as public, private, protected, or anything. Like we just left it. So by default, this is called as a default method. Okay. Now this is in some package called com_basics.access. Now, if I'm going to access this default method from another package, like let's say I have a main control shift F. Okay. I have a main class, and if I want to access the default example, which is in another package, okay, I'm in the com_basics access modifier package, and this is in com_basics access package. Okay, I'm going to access a class which is in the another package. This doesn't allow me. Meaning, if you don't specify anything, if you don't specify the keyword itself, like if you don't specify private, public, or any something, it will take it as default. Those for the default classes to be accessible within your package, you need to put them in within your package itself. If you put them outside your package and if you don't specify anything, these methods will not be accessible for you. Okay. Let's say let's take the same example as a public class. Okay, it's the same example again. A class, instead of void message, I'm going to put it as a public void message. And if I write the public main class here, my class will be accessible, even though my public EX is in a different package. If you see, public EX is coming from basics access package, and my main method is in com_basics access modifiers package. So even though I'm in a different package, just because I added a public keyword here, I'm going to access this void message. I'm able to access a void message from this class, public object equal to object.ex and object.message. If I print this, I'll get this in public method, which is in the public class, public method. Did you get the difference? Like if you don't put any modifier, by default it is void. By default it is default. So if I try to access that method here, it will not allow me to instantiate the class itself. Okay. Next comes your that's the main difference between your default and a public. Okay, when you're trying to access the classes outside the package, you need to know which access modifier you need to use. Now I have declared some variable called as private int data. Okay, so that is 40, and a private void message, which is something. So these private variables are accessible only within the class. Okay, they're accessible only within the class. So even though you create an instance of private in another class, let's say main private. Okay, Control A, Control Shift F. Now I have a private object. I have created a new private object here that is called obj. And if I try to access obj.data, it will not allow me because the field data is not visible. Now we understand why we are using getters and setters. If I want, like I have declared the data value as 40 here. If I want to know what is the value of data from my main method, it will not allow me because I'm trying to access a value of the variable which is private. Hence, what I should, what is the next step? Simply use a getter and a setter of data. Okay. So if I go to my, like, how do I get this now? Now I won't get the error. Object.getData. So object.getData will give me the value of my private variable. But if I directly write object.data, I'm going to access something which is private. This will throw me it will throw me an error. Similarly, if I try to access the message method also, it will throw me this error. So private keyword is used only if you want to access your variables and methods within your own class, not from the other classes. So this is one type of your access modifier. Okay. Next comes your protected. Okay. This is also similar to your public. Okay. I have some class. I declare the method as protected, and I write something called as I'm in protected method. And if I'm going to run this in my another package, let's say public static, this is the main method, and I'm going to um, extend the protected. Yes. So let's take a look at this statement here. The protected access modifier is accessible within the package and outside the package, but through inheritance only. Now, if we take the public example, I didn't extend my public ex method, the class. I simply declared the class. I created an object out of it, and I printed the object. But if I want to do it, if I want to do this for a protected one, like it's the same class. If you take the public, the only difference between this protected example and the public example is the keyword. This is declared as public and this is declared as protected. So if I want to access this public EX, I can simply I can just simply add one import statement, take the public class, create an object out of it, and print the message. But if I want to create an instance of the protected EX method, I cannot. I need to extend it. Okay, meaning protected EX is my superclass and this is my subclass. So what does extend keyword tell you? This is inheritance. Hence this statement. The protected modifier is accessible within the package and also outside the package, but it should be done through inheritance only. If you want to access a method within a protected example, simply extend it and then create a class out, create your own class, your object, and simply put the p.message, call the object. It will print the I'm in protected method. This one, I'm in protected method. This is going to call your protected method. Getting it? Public means you can be anywhere within the project. The class can be in this package, your main class can be in this package. You'll be able to call this class, and you'll be able to call multiple classes within your packages. But protected means you first you need to extend it. You need to extend the superclass and then make your changes. Clear till here? 4 types: default, public, private, and protected. Okay. So we also give a table here. So if it is private, it is accessible within the class, and it's not accessible anywhere within the package, outside the package, and outside the and within your subclass also. If it is a default, yes, it is accessible within your class and within a package itself, but not outside the package and but not outside the subclass. If it is protected, yes, within the class, within the package, and within the subclass only. Means your inheritance. And if it is public, it is accessible everywhere. You can access it within your class, within your package, within your subclasses, and outside the packages also. Clear? So we covered all the Java Oops concepts and your inheritance, your polymorphism, your abstraction, the data hiding, all these concepts. Any doubts still here? Yes, no.
No doubts, bro.
No doubts.
Thanks
Okay.
for it.
Yeah. Then tomorrow we are going to continue with your arrays and strings. If time permit, like we can take care of exception handling also. So we are going to cover these 3 topics.
Okay, bro. Really
Okay.
appreciate it. Thanks for your time.
No problem. No problem. Thank you all. Have a good day all. Thank you.